The whole process was as expected. The result was pretty precise, and the landing was very stable.
What if I told you that while the world was busy arguing about space budgets and new satellites, China quietly landed on the far side of the moon and started mining a resource that could power the planet for thousands of years? This isn't science fiction. This is happening right now. Most people have no clue what's really going on up there. By the time the world wakes up, it might already be too late. The moon's hidden treasure. If you look up at the moon on a clear night, you only ever see one face. The same pockmarked familiar surface stares down at us because of a cosmic trick called tidal locking. For thousands of years, humanity's stories, ambitions and curiosity have been focused on that bright lunar landscape. But in the 21st century, the real action shifted to the far side, the part hidden from Earth's view. This is the place where China planted its flag, not just for glory, but with a clear strategy, to quietly lay claim to the most valuable energy source in the solar system. For decades, countries like the United States, Russia, and Europe have treated the moon as a trophy. The first to land, the first to plant a flag, the first to bring back rocks. Each mission made headlines and history books. But China's ambitions are different. They saw something everyone else overlooked. Deep within the lunar soil lies helium-3, a rare isotope that is virtually non-existent on Earth. Unlike most fuels, helium-3 could unlock clean, nearly limitless energy through nuclear fusion, powering cities without radioactive waste. If anyone could figure out how to use it, they could change the course of human civilization. So how did China get so far ahead in this new lunar race? It started with vision and silence. While other countries publicized every launch, China played the long game. In 2019, the Chang'e 4 mission stunned the world by landing softly on the far side, a feat no other nation had attempted. That mission was just the beginning. With robotic rovers and a series of satellites, China began mapping the hidden craters and gathering vital data about helium-3 deposits. Western space agencies took notice but struggled to catch up, bogged down by shifting political priorities and a lack of urgency. The lunar surface may look barren, but it's a goldmine for anyone with the resources and patience to exploit it. Helium-3 doesn't just lie scattered across the soil. It's embedded in layers deposited by billions of years of solar wind. Extraction is tough. You have to mine, heat, and process tons of regolith to isolate even a small quantity. But China's state-run program didn't shy away from the challenge. They threw the weight of a nation behind the effort, pushing ahead with new landers, more advanced mining tech, and plans for permanent lunar outposts. Unlike the fanfare that accompanied the American Apollo missions, much of China's work remained under wraps. The secrecy was by design. Back on Earth, most people, especially in the United States, weren't paying attention. They saw press releases about new lunar robots or the occasional blurry photo from a rover. They didn't realize the implications. Every mission, every sample returned, every byte of data transmitted back to Beijing built a foundation for something far bigger. China's approach was methodical and relentless. When international news finally reported that Chinese scientists had successfully extracted the first micrograms of helium-3 from moon dust, the world barely blinked. It sounded like a footnote. In reality, it was the first step toward an energy revolution. What makes helium-3 so valuable, anyway? Unlike uranium or plutonium, which power today's nuclear reactors, helium-3 fusion promises almost no radioactive waste. The reaction is clean, producing a burst of energy and little else. On Earth, helium-3 is almost impossible to find. The magnetic field and thick atmosphere protect us from the solar wind that delivers this isotope to the moon. Only a few kilograms exist in laboratories worldwide, used for research and niche applications. On the moon, though, there are an estimated 1 million metric tons of helium-3 locked in the upper layers of soil. That's enough to meet all of humanity's energy needs for centuries. China saw the potential early. They knew that whoever controls helium-3 would control the future of energy. Imagine a world where a single lunar shipment could power a city for years. Oil, gas, and even solar might become obsolete overnight. The economic and political implications are staggering. Control the supply, and you control the flow of power and information. The stakes are even higher because the race is happening out of sight. While the United States debated space budgets and infrastructure, China quietly laid claim to key lunar territories, positioning themselves to dictate terms when the technology matures. But there's another dimension to the story that few outside the space industry grasp. Mining helium-3 isn't just about energy, it's about quantum supremacy. Cooling quantum computers to near absolute zero is one of the biggest hurdles in making them practical for everyday use. Helium-3 is the perfect refrigerant for this task, far superior to anything commonly used today. If China secures enough helium-3 to scale up quantum computing, they could leapfrog the rest of the world in secure communications, code breaking, and artificial intelligence. Suddenly, every secret on the planet is vulnerable, every encrypted message at risk. That's what keeps Western analysts up at night. Space is not just a new frontier,